Welcome to this explainer. Today, we're absolutely demystifying the foundational concepts of network security. Whether you're a total beginner trying to figure out how to secure your personal data, or a seasoned IT enthusiast looking to really solidify those mental models, you are exactly in the right place. Let's dive in. I want you to think about this for a second. If your computer or even your company's entire network is your digital home, who's actually guarding the front door? The internet is, well, it's a pretty wild, untrusted place. Without a dedicated guard, anyone can literally just walk right into your living room. So, here's our roadmap for today. We're going to meet your digital gatekeeper, check out ingress and egress traffic flow, dive into the 4 types of firewalls, compare hardware versus software, pit firewalls against antivirus software, and finally wrap up with the limits of a firewall. All right, let's kick things off with part 1. Meet your digital gatekeeper. So what is a firewall exactly? Basically, it's a definitive barrier standing between your trusted internal network, like your home Wi-Fi or office LAN, and the vast, untrusted outside internet. It's a security system that constantly, relentlessly monitors network traffic. But here's the key. It doesn't just watch. It makes active decisions to either allow or deny that traffic, all based on a strict set of configurable security rules that you set up. To really lock in our mental model for the rest of this explainer, I want you to picture a firewall as your digital bouncer. Imagine a burly security guard standing at the door of a super exclusive club. They've got a clipboard with an approved guest list. If you walk up and your name isn't on that list, or your ID just doesn't match their rules, they're going to look at you and say, "No thanks, you're not getting in." That is precisely what a firewall does with data packets. Moving right along to part 2, ingress and egress traffic flow. Now, in the networking world, we use very specific terms for the direction traffic is moving. Ingress is just incoming traffic. It's people walking into the building. So if you're downloading a web page, that data is attempting to enter your device. Egress, on the other hand, is outgoing traffic, people walking out of the building. Think about when you send an email out to a server. A properly configured firewall absolutely needs strict rules to monitor both directions. You have to prevent malicious data from coming in, sure, but you also have to stop sensitive data from leaking out. When you look at a real network architecture, you can see this flow in action. An outbound request from a local area network or LAN starts moving out toward the internet. It first hits a proxy server, then it travels through that firewall perimeter defense we talked about, before finally hitting the wide area network, or WAN. The gatekeeper sits right at the edge. It acts as the ultimate choke point where every single piece of traffic must be inspected. Okay, part 3, 4 types of firewalls. This is where it gets really interesting. Firewall technology has actually evolved through 4 distinct generations, and we can map these directly to our security guard analogy to understand exactly how they work. We go all the way from a basic ID checker to a highly intelligent profiler. Let's break these down one by one. Generation 1 is the packet filtering firewall. Think of this as your basic, no-frills ID checker. It's fast, but it's what we call stateless. That means it looks at every single data packet in total isolation. It checks the source IP, the destination IP, and the port number. If the packet matches the rules, it goes through. If it doesn't, the firewall might just silently discard it, dropping it on the floor without even telling the sender. The big flaw here, though, is that it has literally no context of the broader conversation happening. So Generation 2 fixes that amnesia problem. Stateful inspection upgrades our bouncer by giving them a memory. It maintains a state table. If you request a website from the inside, the firewall actually remembers that established connection. When the website's data tries to come back in, the firewall doesn't have to rigorously recheck its ID from scratch because it already knows the context. It's exactly like a bouncer remembering you walked in earlier so they don't hassle you when you come back from the patio. Then we have Generation 3, the proxy firewall. Forget the bouncer, this acts way more like a high-end concierge. Instead of just letting traffic pass through, it intercepts it. If you want a file from the internet, you ask the proxy. The proxy physically goes out to the internet, gets the file, inspects it at the application layer, and then hands it back to you safely. This gives you incredible separation. The outside world only ever talks to the proxy's IP address, meaning external threats can never form a direct connection to your actual computer. And finally, Generation 4. These are the heavy hitters. Next generation firewalls, or NGFWs. These are literally the FBI profilers of the network. They don't just check IDs or remember connections, they are actively analyzing behavior. They use deep packet inspection and integrated intrusion prevention systems to block highly sophisticated modern threats. They are incredibly smart, for sure, but they're also a lot more complex to configure and very resource-intensive to run. Let's pivot to part 4, hardware versus software firewalls. So, do these gatekeepers live in a physical box or a virtual app? Well, both. Hardware firewalls are dedicated physical appliances. You literally rack and stack these boxes. They sit right at the perimeter of a campus or data center because they're purpose-built to handle massive volumes of high-speed traffic predictably. Software firewalls, on the other hand, are virtualized. They run on a host machine or a cloud instance. Because they scale so easily, they are perfect for filling the gaps that hardware just can't reach, like protecting distributed workloads and managing the east-west traffic moving between virtual machines internally. Honestly, for a lot of networks, the best strategy is a hybrid approach, using both. Which brings us to part 5, firewalls versus antivirus software. People ask this all the time. Hey, if I have an antivirus, do I really need a firewall? The simple answer is yes. You absolutely need both because they do completely different jobs. While your firewall is guarding the perimeter from unauthorized network traffic trying to transmit over the wire, your antivirus is acting as the internal detective. An antivirus performs file analysis at the device layer to find and stop malicious code that you've already let inside. It's a classic defense-in-depth strategy, 2 distinct layers of protection. And finally, part 6, the limits of a firewall. Look, even the absolute best guard in the world has blind spots. A firewall generally cannot protect against an internal threat. If a rogue employee plugs an infected USB drive into a computer behind the perimeter, the firewall can't do much about it. It also struggles to inspect heavily encrypted traffic if it doesn't hold the keys to decipher it. And maybe most importantly, it cannot stop a user from being socially engineered. If someone falls for a phishing email and voluntarily invites malware inside, the firewall might just see that as a totally permitted, user-initiated web request. So I'm going to leave you with this final provocative thought to chew on. If your firewall is the ultimate guard at the door, what happens when the threat bypasses that door and is already inside the building? Perimeter security is foundational, absolutely, but it is really just the beginning of true cybersecurity. Thank you so much for joining me for this explainer. Keep asking questions, keep securing your networks, and we'll see you next time.